All right, what we're going to look at with this section are parabolas, and we've seen parabolas before several times actually. You've seen them in Algebra 1, and we've talked about them in Algebra 2, but we looked at the form just a little bit differently. So really what a parabola is a series of points that have the same distance from a focus, which is this point P right here, and a directrix, which is a straight line, and from this point here. So these two distances are the exact same. And all the points that satisfy equality of this distance 1 and this distance 2 create a parabola. And the parabola has an equation that actually looks like this as a conic section. So what we're going to do is we're going to look at parabolas now a little bit differently. They're all the same. You've studied them before. You can do these things, but now they're just a little bit different. And what we've talked about in the past has been parabolas that open up and down, which is a parabola that has kind of this shape where you have y equals x squared. But with a conic section, you can also have a parabola that opens left and right, and that's going to be this x equals 1 over 4p y squared. And some things that we need to talk about with the parabola so that you can do all of these things. Number one is the vertex doesn't change. It's that point that we've talked about that is where the parabola changes its direction. It's the bottom or the top, and now in this case it's the left or the right of the parabola. And the distance from the vertex to that point P, which is your focus, is just P units, whatever that is right there. And however far you go to the focus, you go the other direction for the directrix. And that's all you need to know for working with parabolas. And we can find everything based on this. Now, these are equations for parabolas centered at the origin. So if they're not centered at the origin, things will look a little bit differently. So here are those parabolas, ones that are not centered at the origin. We're going to call them centered at HK. Well, just like all of the other conic sections that we've talked about or that you will talk about or see, anything that happens inside of parentheses is going to be the opposite. So if I'm centered at the point HK, then if I have x minus h, that minus h means I move a positive direction to the right. And then anytime I see something all by itself, just all alone, I do exactly what it says. So this k over here, he's not in parentheses. So I do exactly what he says. And this is going to be the y direction right here. The k is going to be y. And it just says move up in a positive direction k units. And so if I'm not centered at the origin, if I'm centered at some point hk, this is what my parabola equation will look like. Okay, so just for a quick example, if I'm centered at some place like, let's say I'm centered at the point 3, 2, and that's all that I know about this parabola, I don't know anything else, then this equation, and I'll write them up here, I've got a little more room, I'm going to have y equals 1 over 4p times x minus 3 squared plus 2. If we look over here at a parabola centered, not centered at the origin, but now is opening left or right, when I look at that guy, let's talk about just all we know it's at the point -2 and 1. Then when I write this equation, and I'll write this one down here, when I write this equation, what I'm going to have is x equals, okay, 1 over 4p. We'll figure out what that is later. We're not concerned about it now. But then my equation is going to look like x plus 2, well, not x plus 2, it's going to look like y minus 1 squared minus 2. Okay, so that's at a point where you're not centered at the origin. So let's graph and identify the vertex, focus, and directrix and axis of symmetry for an equation. And on this, the first thing that I'm interested in is what variable's over here on the left, because that's going to tell me which direction this opens up. Well, as it turns out, the y is. And so this is a parabola that we've worked with many times before, and it's already in what's called vertex form. So super secret opposite society inside parentheses, that's going to be a negative 2. Do what it says outside of parentheses, that's a positive 1. So here is my vertex. Remember, your vertex gives you an x-coordinate and a y-coordinate. Okay, and I can plot that over here on my graph. I'm going to go to negative 2, positive 1, negative 2, positive 1. Let's see if I can get it. Pretty close. And then what I'm going to do is I'm going to now try and find the focus and directrix and the axis of symmetry. Well, the axis of symmetry is the vertical line that goes right through the middle of my parabola, because I have the exact same things on both sides. And it's going to be right here. Well, what point is that? What is that? That's the equation of the line x equals negative 2. That's my axis of symmetry. Well, what about focus and directrix now? Well, remember that the number in front, this 2 right here, is equal to 1 over 4p. And p is the distance from my vertex to my focus. So what I'm going to do is set 2 equal to 1 over 4p. So when I'm trying to find that guy, I'm going to take that 2, and I know that 2 has to be equal to 1 over 4p. Whatever that is, I don't know. And I just solve this equation out. So when I solve this equation out, I have 8p equals 1. All I did was multiply both sides by 4p, and then divide both sides by 8. So I have p equals 1/8. So to find my focus, I move 1/8 of a unit up from my vertex. Just 1/8 of a unit. This will be really hard, but there's 1/8. Not a very close 1/8. But I'm going to move up 1/8. So where's my focus going to be? My focus is going to be at the point negative 2, okay? Negative 2, and then 1 plus 1/8, or 9/8. That's my focus. Well, what about my directrix? Not a problem. Not a problem at all. We just go the opposite direction for the directrix. So, and my directrix is going to be a horizontal line. So I go 1/8 down, and I get this horizontal line right here. Here's my directrix. Okay. And so what equation is that going to be? Well, my directrix is going to be the equation y equals, and now I'm not at negative 2, 1 anymore. I've come down 1/8. And it's a horizontal line. So my equation is 7/8. Okay? And then I can graph my parabola around that. And keeping in mind that my distance across the parabola has to be the same distance from the vertex to the focus, and from the focus to the directrix all the way around. So this parabola is a little bit thin, and I'll see if I can draw it pretty good here. This will be a little tricky, but it's going to be a thinner parabola. It's going to look something like this. Okay? Hey, graph and identify the vertex, focus, directrix, and axis of symmetry for this equation. And now we've got x equals y squared plus 6y minus 2. Well, this is going to be a little bit more tricky. Number one, it's different than we're used to, because now it says x equals y squared. Well, right off the bat, I know that I'm going to open left and right. Okay, I don't know if I open left or right, but I know that it's got to be one of those two directions. And it says to graph and identify the vertex. Well, this is not given to me in vertex form, so what I have to do is complete the square. And anytime you complete the square, you always do it on that term with just x or just y. And you half it, square it, add it, darn it. And so what you're going to do is you're going to take half of 2 and square it. Well, half of 2 is 3, squared is 9. And that's what I'm going to add. And I'm going to add that to both sides. So I have x plus 9 equals y squared plus 6y plus 9 minus 2. And then I factor my y's. So I've got x plus 9 equals y plus 3 squared minus 2. And then to get it to that vertex form, which is really a nice way to look at things, I just need to subtract 2 from both sides. So x equals y plus 3 squared minus 11. I can now do everything that I did on the previous problem, and I'm ready to go. So what's my vertex on this problem? My vertex is the point -3, -11. What's the focus? What's my focus? Well, I've got to figure out what that point is. And so notice that the number in front of my parentheses here is 1. The number in front is 1. So what I'm going to do is set up the equation that 1 is equal to 1 over 4p. Multiply both sides by 4p, and then divide by 4 so that p is equal to 1/4. And if p is equal to 1/4, that's how far I have to move from my vertex to my focus. And so since I'm going to, let's get our vertex up here real quick. I'm at the point -3, 11, which is right off my graph here because my graph has 10 units on it. And so this graph, since it's positive, is going to open to the right. And that means my focus moves 1/4 of a unit to the right, which means that I'm not at -3 anymore. I'm 1/4 of a unit closer to the right. So my focus is actually going to be the point -2.75 and -11. That's my focus. So I'm going to move 1/4 of a unit to the right. There's my focus. The directrix is going to be the other direction, to the left. And so I move 1/4 of a unit to the left. So what is my directrix going to be? My directrix is going to be the line, and notice it's a vertical line now. It's going to be the vertical line, x equals, and then I'm just 1/4 of a unit past 3, or -3.25. So right here. Whoops, that's almost 4. Can't get my big beefy fingers to go to the right spot, but that should just be 1/4 of a unit to the left of my vertex. And so I've got a vertex, a directrix. Now I need an axis of symmetry. And so the axis of symmetry then is going to be the line that splits my graph right down the middle. Well, my axis of symmetry then takes on the equation of y equals the y coordinate, in this case -11. Axis of symmetry. Y equals -11. Okay? And so now can I draw a graph? You bet I can. And so when I draw this graph, I'm going through my vertex. It's going to look about like this. So now use the given information to write the equation of a parabola, and here they tell us where the focus and the vertex. So what I would recommend is that you just make a rough sketch of the information they've given you. We need to know if it opens up or down or left or right or where. And they tell me that the vertex is at the point -2, 1. So I'm going to go -2, and I'm going to go up 1. So here's my vertex. And then they tell me the focus is at the point 2, 1, so that's going to be 1, 2, 1. So there's my focus. So when I look at this guy, I'm going to have a graph, and again, this doesn't have to be super precise, but I'm going to have a graph that does something like this. Okay? And if I'm going to write the equation of this parabola, then I know that I'm not centered at the origin. So looking back at your notes, we're going to have something that looks like x equals 1 over 4p times y minus k squared plus h. And hk is that center. Well, that's the vertex right there. Okay, h is negative 2, k is 1. So when I'm writing this equation, I know right off the bat, I don't know what 1 over 4p is going to be yet, but I know I'm going to have x equals something times y minus 1 squared minus 2. Okay? Well, now I just need to know what that p-value is, and that p-value is the distance from the vertex to the focus. Well, we're looking at this distance right here. Well, how far is that? Well, I'm going from negative 2 to positive 2. How far is that distance right there? It's 4 units. So 1 over 4p, if this is what p is, okay, if this is what p is, then 1 over 4p is going to be equal to 1 over 4 times 4, which is 1 over 16. And now that we've got that guy, we have the equation of our parabola. Okay, so we want to use this given information to write the equation of a parabola. And again, like on the previous problem, what you want to do is just give yourself a really rough sketch of what this is going to look like. So I'm going to go to a focus of 3, 4, 1, 2, 3, and then 1, 2, 3, 4. And I've got this point right here. The point is 3, 4. And that is my focus. The directrix, then, they tell us, is at the line y equals 6. So I'm going to go up 2 more units here. And I'm going to have a a horizontal line right here. And so I know that this distance is 2. Okay? And so I need to use what I know to graph what I don't. And if what I've got drawn is correct, then my parabola has to have a vertex halfway in between, and it's going to open down. Okay? And so how do I get my vertex? Well, just look at this guy right here. He's got to be halfway in between the focus, which is at 3, 4, and the directrix, which is this line right here at y equals 6. Well, the x-coordinate isn't going to change. What's that x-coordinate? The x-coordinate is going to be 3. Okay? Well, what about the y-coordinate? Well, the y-coordinate has to be exactly halfway between 4 and 6. And the exact halfway point between 4 and 6 is going to put us right at 5. Okay? Now, also what we need to look at is which way this parabola opens. It's opening down. And since this parabola opens down, we're going to follow the old equation that looks like this. 1 over 4p times x minus h squared plus k. This is the formula that we're going to use. Well, we can fill in h and k right now. And once we discovered where what this distance is right here, that distance is 1, I now know what p is. So if I have 1 over 4p, and I know that that distance from the vertex to the focus is p, I have 1 over 4 times 1, which is 1/4. Now, one thing that we need to keep in mind, and we haven't seen it yet in these notes, so we're going to talk about it right now, is that if this term, the constant term, 1 over 4p, if that term is less than 0, then you're going to have a parabola that opens down, like the one that we're looking at now, or opens left. Just think about how when you've studied quadratic equations in the past, if the x squared term was negative, you had an equation that opened down. Well, now if you have a y squared term that is negative, you have an equation that opens left. And once we have this knowledge, we can very easily fill in the rest of our problem. Y equals negative 1 over 4p, which is negative 1/4, times x minus the x-coordinate of the vertex squared plus the y-coordinate of the vertex.